Okay, so the basic idea of today's PR is like we will be looking into the address managers, and the address manager is responsible for ensuring and maintaining all the addresses. Like it's the address book of the node. And this PR is about trying to find the total sum of addresses for each of the sub networks. So there are different kind of networks like IPv4, IPv6, CJDNS, and Onion and I2P. So the node will try to basically maintain a sum of all the known addresses for each of the networks. Now, previously, it didn't use to maintain this ad network specific sum. It used to like have the total sum of the addresses that it has in its book. But that has some problem, and there are some extra benefits that we can do by separating the sum count logic. So that's what this PR does. So thank you everybody and for joining today's RIA Review Club. And today we will be looking into Address Manager, and this PR is about setting the sum of setting the sum of addresses that we have in our address book, categorized by network. And today we have Stratosphere guiding us through the PR. So Stratosphere, why don't you take the stage?
Yeah. Hello. So today we're going to review this PR 26847, where we're going to track AddrMan totals by network and table in order to improve this precision of adding fixed seats. We'll go into all that later. But did any of you review the PR?
So the PR is already merged, so I think it has enough
Yeah.
concept and approach ACK. But yeah, in general, it seemed like a good idea to me.
Yeah. So yeah. Do you want to give a short summary?
Okay, so a short summary would be so in our address manager, we had this situation that we had a try table and a new table. The new table stores all the addresses we newly found, and the try table stores all the addresses we found already and already have been connected. And so it also has buckets. So probably we'll go into buckets later. But what this PR adds is like it will produce a separate in a separate structure. It's a map that for each network it will store the new and try it count. And so that's the internal part of the network and change. And I think the major part of the change is happening inside this guy address manager implementation, where it's adding a m connection count, or it's in address manager. I will also have to look.
The
So
map.
I have a question. Like, how are they storing these new and right? Like, which data structure? Hash tables?
No, it's a map.
Okay.
Let me try to
Okay.
find that portion where it got added. Did you find it, Satisfy? Like where the new map is getting added?
Yeah, this one, right? Wait, are you asking about how the new table and try table will go to the memory?
This one,
Yeah, yeah.
basically this new try it count. So this is the new structure that got added in this PR, right?
Yeah.
Yeah. So basically, this new structure is now maintaining, and it's guarded by a critical section, and it's basically maintaining. So if you see on the type definition, standard unordered map of network and new try count.
Hmm.
So basically, it's a standard unordered map.
Yeah.
Yeah. Oh yeah, I think the Fractal's previous question, like this is Adderman, this is Address Manager, essentially just this class, and you store it into peers.dat file.
Okay.
Peers.dat is this thing in .bitcoin. So
Yes.
so it is serialized and stored into peers.dat, and when you restart a node, you'll read this again, and
Right.
Okay.
and it also has it will store all information. The ones we are interested in, as Raj said, is this number of tried table entries, like the tried table and stuff like that.
Peer peers.dart has some addresses by default, right?
So at the start of the node, it will like when you are starting a first node, it doesn't have a peer.address file created.
Hmm.
So what it will do, it will try to use some seeds. There are some hard-coded DNS seeds from which it will try to fetch some addresses. So then it will like get its initial list of addresses from the hard-coded seed and create the first
Correct.
peer.address.
Where are those seeds again?
I think I have to search.
For example, even Peter Todd and these guys,
Yeah.
the Luke
Yeah,
Dash,
they have their
they have
seeds.
their seeds inside the code, na?
Yes.
Oh, fixed seeds are different from DNS seeds.
I don't think so. It should be same.
This is the fixed seeds list. Like it's hard. Like when DNS seeds fail, you do fixed seeds. Yeah, this thing.
Okay.
Uh,
So
I just have a confusion. Like there are two screens together parallelly running, right? Uh,
yeah, so I'll
I,
just stop my screen. It's not being used. So yep.
Okay. Yeah. So, uh, yeah, fixed seeds is this hard-coded set of seeds. Like supposing you ask the SIPAs and Peter Todds and all those nodes.
Hmm.
Sorry, not nodes, those crawlers, and you'll get a set of addresses. That is the first mechanism you do to get addresses. Supposing that does not work, you query fixed seeds. These are like hard-coded seeds kept inside this file, chain param seeds.h.
Right.
Okay, chain pattern
So
seeds.h. All right.
Yeah.
so in the chain params, so there are like different kinds of params, like signet params, mainnet params, testnet params, and probably inside that, if we look into the mainnet param, we can see the seeds, like the DNS seeds. It's there.
Yeah.
Yeah. If you go to chainparams.cpp and see main params,
Hmm.
and yeah, just below around line 123, uh, yeah, somewhere around there, 123. Yeah,
Yeah.
these are the seeds. So yeah, it has some blue mats, dash juniors,
Hmm.
Peter Todd, and SIPA and all this. So this is where the ad. So if this fails, then it falls back to fixed seed.
Hmm.
Yeah.
so these names, like they are the maintainers of Bitcoin Core. Like these uh,
They're
Peter, Google.
volunteers. Like even you can
Okay.
run if you want.
They're people, yeah.
Yeah.
So some of them are maintainers. I think no, I think none of them are maintainers right now, right? Because SIPA like dropped down. But yeah, it's kind of off topic. But yeah, these are the people who are like hosting. These are like DNS addresses, and if you query this DNS address, you will get back a bunch of Bitcoin addresses. So you can even host your own and can add into this list also. But yeah, you need to keep on maintaining them.
Yeah. And hopefully, eventually, we'll remove those.
Yeah.
But
All right, moving on.
yeah. So where were we? Yeah, we were talking about AddrMan. And
Yes.
just another basic definition, like new table and try table, just in case. New table means addresses which are stored, seen for the first time. You store that in new table. And try table, you store the addresses with which you have already attempted connections.
Right.
Just so that all of us are on the same page.
And I'm guessing these tables are flushed every time your node shutdowns, right?
Yes.
Yeah,
Okay.
yeah. And we'll start with the questions. When is a network reachable in Bitcoin Core?
Yeah. So, yeah, this is like a tricky question. So the easy answer I could find is like when the network is not reachable, we kind of take it as reachable, and this seems to be happening inside at the top of net.cpp. There is a global variable around line number net.cpp line number 119.
Yeah,
So this VF limited vector, which is guarded by this global mutex, is a vector of seven items that defines the seven different kind of network, and it starts with all false at the start, right? That's how it starts defining, and then there is this guy called set reachable. I think, where is this one? Set reachable, and it's happening in init.cpp. It's defined in net.cpp also, net.cpp 325. Yes. So this guy is basically saying like, if this network is passed on as Boolean reachable, so then put the corresponding negative value in VF limited net. So basically, um, wait, what's happening here? If it's reachable, then we put it as false and limited net. So VF limited is a set of network which we don't, which we are not reachable in, right?
Yeah.
So these are the limited networks, and if whenever we are setting some network as reachable, we set the corresponding network table as limited equals to false. So by looking at the limited table, we later on figure out what are our reachable networks.
So by default, every network is reachable, and if we are not able to reach it, we mark it as unreachable, right?
Yeah, so by default, all the networks are reachable. At least that's what I am reading from init.cpp. And in init.cpp, if you search for set reachable, there are only 4 places it is used.
Okay. Okay,
Yeah.
1 minute. I am a bit confused. Wait, limited and reachable are opposites.
Yes.
Okay,
Yes.
but okay, I'm getting that. Yeah. So initially, I think the line you showed, everything was like limited. Everything was false. That means all
Yes.
networks by default are reachable because
Right.
limited is false.
Right.
I got that. And
And then in we init cpp, so here the code is basically setting reachable equals to, so here was my confusion. So the entire 4 places of init.cpp where set reachable is used, it is set as false.
yes,
So reachable is used as false, so the entry got set into v limit table as true, right?
yes,
And so later on, after like this line, then there are like 3 set of reachables where it's set as false. So it's setting pjdns as false, it's setting onion as false, and it's setting I2P as false
hmm.
if certain conditions are not met. So I guess by default these networks will always be false, right?
By default, these networks are reachable.
No, it's reachable equals to false. So
By default, all networks are reachable. That's correct, right?
no, I think by default it doesn't go for I2P and Tor or CGDNS. It will look for some settings. If the, for example, if the I2P server is there and I2P proxy is running, then only it will set it reachable with some flags that it will be trying to find.
I can barely open the tab where it has the discussion, but I think I read before the call and it mentioned that by default it's reachable, but I might be wrong.
Okay, could be. I could be also wrong. It seems to me like the init is like, if we don't set any kind of like configuration for Tor, I2P or CJDNS, init will like go through this code and put set reachable equals to false for each of them.
Okay, okay, oh, all right.
And this is happening, and and the first set reachable is also like putting things into false. So that's where my confusion is. Where is set reachable putting things as true, or it's not
Yeah.
putting things as true at all anywhere, because we are inferring reachability by looking at that v limit, vf limit network vector.
Exactly. So, like we said, like you showed the line VF limited, it's always false, and limited
Right.
and reachable are opposites. So,
Right.
when we say it's false, we actually mean everything is reachable. Like all reachable is actually true. Like if you think of it like that way, in that way.
Okay.
So that
Okay. So
means, yeah,
VF limit starts with everything equals to false. So
yes,
that means like everything is reachable at the start.
exactly. So that
Okay.
means you have to set reachable as
Things as
false.
false separately.
Yeah.
Okay. Okay. So here in this logic, what is happening is like if we set only net arguments,
Yeah.
it will basically take that network and put every other network as false. Right?
Uh, okay. We have, okay. So nets has the net too. So like supposing we set only net is tor. So nets right now has the set with only tor.
Right.
So the count of tor in the sets will be 1 and let's say IPv4 is 0.
Right.
So when we come to this statement, like if this has to be true, that means nets dot count should be 0.
Right. So for Tor, we will not put it at false, but for IPv4, we will go ahead and put it as false.
Yeah, exactly.
Makes sense. Makes sense. Yeah.
Yeah.
Mm, So, we don't have any other question on reachability, but there have been some discussion that was like good in the thread of this chat also was there, also in the peer thread also it was there that previously there was a each reachable is reachable vector like VF limit network. It
Hmm.
was like a vector of network which are reachable,
Hmm.
and later on people said like it's confusing because we are tracking limited and reachable parallelly, and it's more pain to maintain consistency. So there was a PR that like removed that ease reachability in favor of VF limited. So by only at the limited flag we could say it, but there was like also another like old PR that was having some discussions where they were saying is like there is no good way to figure out whether a particular network is reachable or not, and there are certain nuance between inbound reachability and outbound reachability, and they are not the same thing. So yeah, some kind of discussion was happening previously regarding that. So that's why probably the comment says it's not self-explanatory as it was seen.
Yeah, that makes sense. This concept is interesting because like we're not actually checking whether a network is reachable.
Yeah,
We don't
we're
connect
just
to it.
checking whether certain network has been specifically marked as unreachable or not.
Yeah, exactly.
So like if set reachable is set to false, it means like it is reachable, right?
No, set reachable set to false means it's unreachable because v limited will be put as true then.
Okay.
So if you go with the definition of set reachable, it will be clear.
Yeah.
Yeah. So this is the reachable, and it's the opposite of reachable will be stored in the VF limited. So if set reachable is false, then VF limited for that network equals to true.
Okay. 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 Got it. And by default, Tor is not reachable, right? Or
So I guess like
Yeah,
by default everything is reachable,
exactly.
but
okay.
then if it at the start of the process the node doesn't found like a proper Tor relay configured with everything, and it cannot connect with it, then it will basically fix it, mark it as a non-reachable then.
Okay.
All that is marked in this app init main function.
So there's Tor, there's I2P, there's ClearNet. What else do we have as a type of networks?
We have another called CJDNS. uh, yeah, I think that
Yeah,
enum network. Yeah,
Oh, it's
yeah, these are all
in
the
an
types.
enum.
yeah, it's in
Hmm.
an enum, and
Oh,
there is
IPv4, IPv6.
there is a network type which is called net internal,
Hmm.
and that is interesting. And I don't exactly know what it is used for, but um, it says like this is that this is the network that is assigned to DNS seeds.
Hmm.
Oh, Okay, am I going off track? Like I do not know.
Yeah, let's fall back to the
Yeah.
Yeah.
question. I think that was like quite good exploration on reachability.
Hmm.
So let's move on.
Yeah. How are addresses relayed over the peer-to-peer network treated depending on whether they are reachable versus non-reachable? Do we store them and or do we forward them to peers? You can
Right.
go
So
first.
it seems to me that by default, what we are doing is if the address is not reachable, we will not store them, but we will relay them to the peer. And this is happening inside peer manager implementation. And let me find the line. Sorry.
This one, right?
Yes, right. So this one. And here, what it is doing is like trying to find out if reachable, if this net address is a network of reachable, and then it's passing that f relay flag to relay addresses, and then using f relay flag and saying like if f relay if f reachable,
Hmm.
if it's reachable, then it's storing in the address next, in the vector next. And there are something cool happening with this if reachable inside this relay. This relay. What is this? This relay. Relay
Address.
address. Yeah. So at the first line, it's basically returning a null. So if the net address is of not reachable and is also not reliable, we don't relay this address at all.
Hmm.
But if it is reachable, then it does some randomness at the end. So
Yeah.
here, so it's saying like if it is reachable, then send it to two peers. If it's unreachable, then randomly either send it to two peers or on one peer or a single peer.
Yeah.
Hmm.
And for all reachables, we just store them, but we don't store unreachable addresses. But we might like relay them.
Exactly.
So the concept might be that that address might not be reachable from our node, but it might be reachable from someone else's node.
Yep,
Okay.
probably yes. So, and we want to maximize our address data book only by our reachable nodes, so we don't want to store them, but other peers might be interested into them, so
Hmm.
we send it to them.
Okay.
This 2-1 ratio is like randomly selecting 2 or 1. It's kind of interesting. Like,
Yeah, and it uses a like hasher somewhere. Like it uses a hasher. This hasher is basically a hash of this object, I guess. Like I don't know. And then it tries to find the hash and get the first bit of the hash. If and it's like almost 50-50 whether it will be 0 or 1. So in the unreachable case, it's like 50-50 chance of sending two address or one address.
yeah, I want to draw one thing like fast. Like it's uh, okay. It's kind of interesting why. Like, what if it was only one? Like, why do we need to randomly choose between one or two?
Okay.
Do you know the answer to that? Like, that's kind of interesting.
So you're saying like why not just unreachable one send it to two all the time? Why we need to randomize it?
Yeah, why do we need to do one or two? Like, what's wrong if it's only one or
Or only two?
only two? Yeah,
Okay. No, I don't know. That sounds
yeah,
like an interesting question.
yeah. It's kind of interesting. Like, supposing this is our node and we have like 5 Tor addresses, and
Okay.
supposing f reaches one. Reaches one means you will send it to exactly one node.
What do you mean by reaches one?
Uh, Sorry, relay nodes, like the number of nodes you relay it to.
Okay. So so first one is a relay node.
Yeah, like here basically we are randomly selecting, like end relay nodes will have two values, either two or one.
Right. Yeah.
So,
Okay.
so basically we are trying to understand how for unreachable networks, how the relay happens.
Okay.
So if you're going to relay only to one node, so like if there are 5 Tor addresses,
Mm-hmm.
like it should relay maybe like 3 of them would go to this node and 2 of them would go to this node.
Okay.
So if it is 1, like the sum of this would always be 5. Because you're only going to relay it one time, and that too to one of these nodes. But
Okay. Which one is my node? The left one.
yeah, this is this is your, like I just meant it like this is the source.
Okay.
Okay,
Okay.
yeah,
Okay. Okay. This
okay,
is
yeah.
the source, and that guy sent me. Okay. Like now it makes sense. Okay. So if it's only one, so we will randomly select for each address. We will randomly select either this node or that node.
Yeah, we will, supposing there are 2 pairs, like imaginary situation, you would
Right.
send it only to one node, and the
Right.
total number of Tor addresses you relay would be 5.
Okay. Yep.
But supposing it was 2, like you're relaying it 2 times.
Okay.
So that means it's possible that you would relay one address twice to each node.
Mm-hmm. Yes. So
So
there will be 5 over there on top
yeah,
and 5 at the bottom. So we relate total 10 addresses.
yeah. This time it's total 10. So if we set it as a, if you randomly choose between these two, it would
Mm-hmm.
you would relay 5 Tor addresses some value between 5 and 10.
Mm-hmm. Okay.
So it could be 6, it could be 7, it could be 8, 9, or like any value between 5 and 10. So that branching factor, you have increased it. If it was only 1, you would only have sent it 5 times. And if it was
Right.
twice, it would be exponential. So
Right.
now you have
Okay.
reduced that branching factor to that limit.
Right. And these relay nodes are selected randomly?
Interesting.
Before the, why not just like twice to every node then? Why do we? I don't get it. Why does it have to be random?
Too much bandwidth. Like, why do we need to? I mean, it's not resource efficient to, like, if it's unreachable, it's not resource efficient to always send it to 2 nodes.
Okay.
Right.
It's a
Okay.
game theoretic decision.
Right. And there are like lot of attack vectors, right? Like somebody can make by sending a bunch of addresses to a node, and so there are like these are like the precautions that the node uses while like trying to relay addresses or
Yeah.
process addresses.
Yeah, even this is called, I think, only when that 10 addresses, like in the code we showed, like, wait, what is the name of this function? Relay address, right? Where was that file?
I think it's relay address is in net processing on net.cpp.
Yeah, here, net processing. So, like, yeah, we would only call it if that address packet we received had less than 10 addresses, less than or equal to 10. Only
Okay.
then we would relay these addresses.
If it has more than 10, then we will not relay these addresses. Okay.
Yeah, it wouldn't get into this function call.
Okay, that's interesting. Okay. So that's like a guard we have by default. Like if you throw me a bunch of addresses, I'll not just relay.
Exactly.
Okay, that's cool. And
I was just gonna ask the relay of these addresses. This just happens on a clear net, right? This is not even encrypted so far.
Yeah, this is all clear net.
Okay.
It's not encrypted.
All
but
right.
if it goes through Onion, then it will be like Onion encrypted, right?
Yeah.
Okay.
Depends on the connection, like what that connection is with our peer, whether
Got it.
Onion or ClearNet. Yeah. Okay. I don't think I have other questions on this. Uh,
Anyone else
there,
has?
Yeah, let's move on to the next one.
Yeah.
yeah.
So, how does this PR attempt to make sure there are no bugs causing the added counts per network to fall out of sync with other AddrMan internals such as NU and NTRIDE?
Yeah. So my first answer to that was like it seems like all the places where um it's using this n new tried and n new. So all the previous places where n new and n tried got added or incremented, this also increments the internal the m network counts n tried and n new. Uh, except for one situation where it seems like where it's deserializing the address and let me find where in the code. Hmm. It's in address manager.cpp line number 303. Uh, yeah, this is a function called check address manager or mm,
Mm. It is unserialized.
no, I'm sorry, I'm sorry. No,
This
this is
one?
unserialized. Yeah, this is unserialized, and it's saying like in that segment, um, yeah, in that segment, there is a section where network counts, network get info, entride is incremented, but I don't see like the global entride incremented in this logic.
Hmm.
But yeah, this is just a we don't have to answer it, but this is just a note I noticed like this is the only place where I'm seeing like the internal network count is incremented, but the global entride is not incremented. And probably there are some nuances going on in this code and it is getting incremented. I'm just missing it.
Yeah.
Yeah, that's another observation on this. So the second part of the question was there is this function inside net.cpp check address manager.
Oh, it's because of this. Like we are direct. This is unserialized, right? Unserialized means we are going to read from the disk.
Okay.
So we have directly got that value of NU into the disk. Like we
Oh,
have
okay. So
already
NU
got.
and NTRIDE are already written into disk, but this M network count is not.
Exactly.
Ah, okay. That's why this thing is happening here. Okay, that makes sense. So we are basically reading that value from the disk and then like going through each addresses, we are basically updating the internal count according.
Yeah.
Okay, okay, that clears that up. So I guess the real answer for the question is like inside address manager CPP, there is a check address manager, and check address manager has this uh, checks at the end, which shows yeah, line number 1101. Yeah.
Hmm.
So this part of the code basically I think is doing the sanity check and checking whether the count matches up. And if it doesn't, then it throws an error.
Yeah.
Hmm. This is interesting, and yeah, it's
You
basically
want to delve into it? Yeah. This is interesting. But it's a code detail. Like, do we have time?
yeah, I think it's a code detail, and it will be interesting to parse this out. I also haven't parsed it, but it seemed like this is the place where the sanity check is getting added
Yeah.
and to maintain consistency.
Yeah. This is, I think, a test only option. This flag, check AddrMan. Like in bitcoin.conf, you can pass this flag check AddrMan after how many operations you want to do the sanity check. Though it's
Okay.
something used mostly by
Okay,
people.
so it doesn't do it automatically by default.
No, it does not.
Uh-huh. Okay, that's interesting to try to run it and see what output it gets.
Yeah, it should do the sanity check all the time.
Hmm.
But it's costly too. So
Yeah, it's kind of costly to handle this. So I think like no other places misses this consistency, right? All the other places already have them paired up, and
check Adaman again does the count again. Like it makes again a new data structure called local counts and checks and finds for each networks and updates the count in tried and new table.
right,
And towards the end, it would check if that value matches with what is there in our actual Adderman. And if
right,
it doesn't, it would return an error code.
right. Makes sense. Okay. Um, is there any other salient point around this? Like, what happens if there is a bug in these two consistencies? Like, and if we are not running check adderman,
Hmm.
then this will not trigger, right? And there it doesn't seem to be any other places where it will cause any problem. Yeah, good question to
Yeah.
ponder.
I'm sure there are like couple tests written to make sure
Mm,
this doesn't
yeah,
happen.
the questions doesn't go into the tests, but there are some. There is a commit that changes something in the test, but nothing substantial.
Hmm.
But I think it's valuable to go through those tests also, the address manager test, and that kind of like demonstrate how the address manager itself works,
Hmm.
which is kind of cool. So it's in the test folder, address manager tests, and it's very simple to read through. And at the end, it added a new test. So address manager side, the last test case is called address manager size,
Hmm.
at the very last case, and that was the one added inside this PR. I think it's good to see how like the different sizes are being returned for different addresses. Right. So when size goes with null option, it means gives the size of all the networks.
Hmm.
And then when we were saying size, network for IPv4 and null option. So null option is for even new or tried. So remember we had two tables, new table and tried table. So this size is a basically function that given a network and given which table you want to look for, it will give you the sum of the addresses in those tables. So if we pull null option, then it's looking into both the tables. If we put in new equals to true, only new table, in new equals to false, only tried table.
Yeah.
Okay.
Yeah. So this was cool, and I found like in general the tests are very easy to identify how an internal structures are supposed to be used. Like internal APIs, the function APIs are supposed to be used. So that's a good place to look at while also reviewing peers.
Totally.
Awesome. Moving on.
How can a node currently get stuck with only unreachable addresses in Adderman, finding no outbound peers? How does this PR fix it?
Right. So I think the only option, the only one I could come up with is like when you have an only net setting. Say, suppose we are doing only net IPv4,
Hmm.
and then we changed our setting and said like only net onion. Now
Hmm.
our address only stores IPv4 address, and now we change to only net onion, and the node starts up and it looks into this pr.dat file and it goes like I don't have any onion address, so I don't know whom to connect.
Yeah. And it would only, before this PR, it would only query the fixed seats when the AddrMan was totally empty.
Totally empty, right? So
But
in this case where I have like full of IPv4 addresses, it will not call the fixed seats
yeah,
because it will go like, hey, you have addresses, so I'll not call the fixed seat. But at the same time, you don't have address for the specific network you are connecting.
so this code will also like, now they've changed it to find the empty reachable networks too.
Right. I think part of the code is also interesting to go through. This get reachable empty network, and
Like all networks, whenever we want to go through, iterate through them, you use that enum network, which we saw
mhm.
before.
Right. And then if the network is unroutable or internal, then we don't do anything. And this function is basically returning all the networks for which we don't have an address for. And this is the point of this PR. Previously, we didn't have this network related totals. So by looking at the network related totals, we can find which of our network doesn't have any address.
Yeah.
And then later on in this connection manager thread open connections, it's basically getting this empty reachable networks, and and then it's saying fix it networks get a reachable empty networks. So it will give me all the networks for which we need the fixed seeds, and if add fixed seeds and not this all the network is empty, then we go ahead and add fixed seeds.
Hmm.
Right. So that's what this logic is doing over here.
How many addresses in total do we save for all networks, or there is no limit?
There is a limit, I think. So, huh. I think there are some variables where this is defined in
Okay.
net.cpp. At the very start of net.cpp, where are the buckets defined? Like it's there in the bucket. I remember seeing it in the buckets.
What limit?
The number of addresses in each bucket. So n new had like 256 buckets, and n tried had like 1024 buckets, something like this. I have trying to find it where it was. Address. So this is inside address manager.cpp, line number 27. Here, right. So so this is like log2 number. So this is like next variable is address manager tried bucket count. So this is like 2 to the power 8. So
Hmm.
tried bucket count is 2 to the power 8. So 256 tried buckets we have. And then address manager new bucket count is 2 to the power 10.
Okay.
Can you see it? Uh,
Yes.
okay, I think well, you are in master, right? So
This one got merged, right?
this one got merged, yeah. So I'm basically opening that PR branch. So probably I'm seeing an older version of the code. But I think those are the variables. At net.cpp. Um, which file is this? Oh, sorry, this is address manager implementation.h.
Oh, okay. Yeah, or I can get it here. AddrMan new count,
Yes,
count
yes,
is
yes. From this.
1024. This is 64.
Yeah.
Right is 256 and 64.
Right. So
Okay.
in one case it's 256 times 64. In other case it's how many? 1024 times 64. So it even like so they are storing it as a bucket. So each bucket has like maximum 64 count place positions, and there are like two kinds of bucket: new bucket, tried bucket, 256 new buckets, and 1024 tried bucket.
Okay.
Hmm.
Yeah, this was interesting. This is like a good details on how address manager is like managing these internal structures.
Yeah.
And and there are like a lot of um, there is this another function that is called is terrible, and it's in
Hmm.
addressmanager.cpp, and this is like a metric that uh, yeah, this guy. So this is like a metric that says like whether a particular address is terrible or not.
Hmm.
So and there are like many other matrices like this where like the health of the addresses are monitored and the scores of addresses are being monitored. Then there are some
What does
randomized.
terrible mean? I mean, it means it doesn't work, or is it like malicious, or what
It
does?
means like if given a chance, we want to throw this address out from our dictionary.
Got you.
There's an interesting history to it, like how we got this AddrMan, uh, this structure, that class AddrMan. Back
Okay.
in the day, like I think before V 0.5, like before 2015, all they did not have this AddrMan data structure at all. They
Mhm.
used to directly, they had this file called adder.dats instead of addressman. It was like a BDB database. And
Okay.
whenever addresses come in, they would store it there and it would periodically flush it. So
Okay.
that we did not have this fine level of control, like is terrible and stuff like that.
Hmm.
Okay. Okay.
And now, and then there was one PR SIPA made, which introduced this address manager with this new table, tri-table structure.
Okay. So now and then it does a lot of like randomness, right? And
Yeah.
a lot of like shuffling around so that it tries to maintain like we don't get only one specific kind of connection in a particular network, and we diversify the network very well.
Yeah.
Even that encrypted P2P is coming soon, right? That's somehow
Yes.
related.
Yeah, this I kind of wrote long before about that history. I'll share if you're interested.
Nice. Yes, please do. We'll put it in the description also. Cool. Okay. Um, any other thing we can discuss on how a node can get stuck and how does this peer fix it? So we haven't talked about this, I guess. How does this peer
This,
fix it?
oh yeah, we
And
talked a bit.
well, we kind of did. Yeah. Basically, it's seeds.
Yeah.
It's basically seeds. Huh. Okay. Cool. That sounds interesting. And yep, we can move on.
Why would it be beneficial to have an outbound connection to each reachable network at all times? Why is the current logic in thread open connections insufficient to handle this, guarantee this?
Right. So I don't know. I guess the one benefit could be like protect against all kind of like those kind of attacks like Eclipse and all. And so there was also this comment by somebody in the previous chat was that that the node will try to randomly select addresses from the address manager, and the current at present, which was the current when this PR was done, the the open connection thread will basically randomly select connection from your data from your dictionary. And imagine if you have 10,000 IPv4 connection and only 10 Tor connections, so it's high probable that you will only start with Tor IPv4 connections only,
Hmm.
and the Tor's connection will not be hit or until some Tor node makes an inbound connection with you. And so so that's why we wanna like have this initial setting where if we have like four networks reachable, we wanna like distribute the connection between four networks equally and not just randomly select data from the dictionary, and be a little bit intelligent about it. So let's say randomly we select from the IPv4 only three nodes, then IPv6 only three nodes, and Tor only two nodes, something like that. Does that make sense?
Hmm.
I think that's the last part. Randomly select for what?
Means like we wanna select randomly between all the IPv4 nodes IPv4 addresses we have, right?
To relay them or to make
No,
connection.
to make the connection with them at the start.
Oh, that is not being done yet, right?
I haven't checked, but isn't being done yet, or it's like still like randomly chooses from the whole list. So I guess like the point of this PR is like instead of randomly choosing from the whole list, choose from the connection specific buckets or the connection specific list or something like that.
Yeah, I think they mentioned that as a future step.
Yeah, that as a future step, but I don't know if that got like done already or not. I haven't checked in
I,
the master.
I don't think so.
Okay, probably then that is not done, but that is like a future scope
Yeah,
where
definitely.
and the problem for that is basically this, right? So if we have a large number of only one specific connections, then it's high chance that we will start off with those connections.
Hmm. Yeah, that's why they were, I think, talking about AddrMan with like network specific AddrMan.
Okay, so later on we want to have like network specific AddrMans, like mhm,
Yeah,
that does make sense. Hmm.
it is mentioned in some issue.
Okay. So why is the current logic in the thread open connection insufficient to guarantee this? And can we like find out the part of the code in thread open connections
Hmm.
where um, where we are seeing like the problematic logic, like why it doesn't do it? And try to find it. Also.
Yeah, that is the one we looked at. Thread open connections. This.
No, like initially, like currently, what's the problem with thread open connection? Like why it will still not distribute the connections between all the networks? The second part of the question.
Oh, each network. Okay.
I mean, a user might not be connected to some of the networks, then it doesn't make sense to even open a single connection there.
Uh, yeah, it doesn't. But like, it would be nice if we could propagate all addresses throughout the network, so that like we should, so that I'm reachable by the people who I share the same network with. If no one
Hmm.
propagates my address, my I will not be reachable. So for the whole network's health, it would be
Okay.
better if some kind of propagation happens.
Okay.
Hmm.
This one.
Like this is like another question. Like I would like to like identify the part of the code where it's like it's like falling short on doing that logic. It's a pretty involved thread. A lot of thing is happening inside this one thread open connection. So probably we can take some time later to figure that out.
Are you talking about the fixed seeds part? Like,
No, I don't think it should be inside the this logic will be inside the fixed state part. I'm just trying to identify where the selection of addresses is happening from the database for making the connection.
adderman.add. Adderman.add. Adderman.add inside thread open connections. How it happens.
Okay.
Wait, are you looking for like where it's added into the new table, try table inside?
Mm-hmm.
Wait, what is your question? I'm confused.
My question is like the second part of the question, like why it is falling short, why this current logic is insufficient to guarantee this.
To guarantee connection to each reachable network.
Yeah,
So in thread open connections, where are we making connections to?
exactly.
Okay, right now we don't have other networks to make connection to, but inside open connections, how are we opening connections to peers?
Exactly.
Okay. Open connection should open a connection. Where is that happen? Oh, open network connection.
Yeah. So this is happening at what part is saying address connection is valid if it's a feeler connection. What's a feeler connection?
Like if you want to make sure a node is like you got some address from some peer, and
Mm-hmm.
you don't know if you don't you're just going to make a feeler connection just to feel if the node is active or not. And if it
Okay.
is, in future we would uh, connect to it.
Okay. Okay. So we are not like establishing a connection with this, just like seeing with the node is alive or not.
Yeah, it's a very short-lived connection, 2 seconds.
Okay. So where it is getting this address to connect to this adder connect. So its adder connect is coming from.
Okay, let's search. Choose a network to connect to based on most recently seen. Where is that query?
Okay. So it's trying to reading the anchor here.
Yeah. If,
Right.
if it's an anchor connection, the adder connect would be
Added.
some,
Yeah.
some anchor. If it's a feeler, it would be, wait, what is this code block? Okay, anchor connection. Yeah, I think we need to take time, like just to look into
Yeah.
it.
Yeah.
Do that later.
Yeah.
Bifactoral.
See you, man. Okay, we can move on. And
We can do it after the recording.
yeah. And the last question is, what is the next step forward for this PR? I think that's what we discussed already
Yeah.
about making this like a outbound connection at the start from each network.
Hmm. Yeah. It's a future plan.
Right. What else could be it useful for? Having the separate counts.
Uh, for development, RPC with all this information exposed.
Right. So currently, is there any RPC that exposes this? I think get peer network info is exposing whether reachability is there, but oh, net info basically says a total of each each network types,
Yeah.
right?
Yeah. I think get network info. Wait, you were talking about net info.
Net info, yeah. So dash net info, and here you can see like the total IPv4, total IPv6.
Hmm.
Yeah, I think like previously before this information wasn't available and net info wasn't able to show it. Now it
I,
can.
I made a PR for that actually. It's like he had mentioned, Martin and Amity had mentioned.
Okay, okay. So you did the PR which exposes this.
Yeah.
Oh, that's cool. That's super cool. Maybe we can do review of that one next. That will be nice. Some RPC additions.
Yeah, good.
Okay. I don't. I don't have any other further or topic to cover on this from my side. Any other corollary thing that you can think of related to this?
Nothing from my side.
I neither. Except
Okay.
you have to dig later.
Yep. Yep. Okay. So this has been fun.
Yep.
I think I'm stopping my recording here. Okay, thanks guys. This was a
Awesome.
very
All
nice
right.